power losses here. And it looks like this. This is like okay. So this was when we wanted to turn the switch on. Okay. Let's do exactly the same thing. Let me just remove this one here. Let's do maybe continue these. And let's say at this point, I want to turn it off. Okay, so here I'm just like drawing the switching losses, not the other conduction losses. We already calculated them later, so I'm gonna ignore this the conduction losses here. So I'm like we're only doing the switching losses here. So let's say at this point we stop the gate signal. So what happens here is that okay, so let's just like at this point the voltage is basically starting to rise up again, and once this happens the current it's gonna come down. Okay, so again this time we have a T rise for voltage and a T fall for current. Okay, and again when you're turning the switch off, this is what you're gonna end up with. Okay, so this is like the power losses when you turn the switch on. This is power losses when you turn the switch off. Okay, so let's just like write the formula for these two like triangles. So for P on, okay, it's gonna be, let's just like call this one T on. Let me see like how this is done in your, yeah. So usually like you're given like a T on and T off. Okay, so P on, it's gonna be, first of all, let's just like do the energy. The energy that's gonna be lost during turning the switch on, it's gonna be I switch on. So this is this value here, right? This is I switch on times VI. This is like this value, VI, times T on, which T on is the summation of these two. If these two add them together, you get T on divided by 2. This is the area of this triangle, right? This is T on, this is base, half of base times height, and height it's gonna be this voltage, this current multiplied by this voltage. So that's basically the energy that gets lost. If you want to calculate the power, right, P lost, it's gonna be, you have to say like in 1 second how many of these cycles we're gonna have, like it's F switching multiplied by that, right? So this is the P on, and P off, it's gonna be exactly the same thing, but instead of T on you would have T off, and like you'd say like I switch off multiplied by VI multiplied by sorry, this is O DC, and this is the same. Like, let me just write this like, okay, this is this current. It, like in the notes it calls it IODC, so I'm just gonna call it IODC. F switching times V in times time off divided by 2, and again T off, it's this time plus this time. TFI plus TRV. Okay, that's how in your notes you have the P loss of the switching. The formula, it's given like this. Let me just write it down here. Half of, let me, P loss switching, it's equal to F switching. Let's take the divided by 2 out, multiplied by I of switching on, multiplied, T of switching on, this is the base, plus, multiplied by VI, which is this voltage, multiplied by IODC, divided by 2, plus T switch off, which is this base, times height, which is V in, multiplied by IODC. Okay. Again, this is a very simplified model to calculate the losses, but it's better than like ignoring it, right? Like, because it's not going to be exactly like this. It might just not end up here. We might have some oscillations here, but this would at least take some of the losses into consideration. So this is how you calculate the losses here. Okay, so this one was one part of the calculation for switching losses. We're almost done. Just be a little bit more patient with me, please. There is one thing that we haven't considered yet, and that's also related to losses for diodes. And we have to take that into consideration as well. So one thing that we haven't considered yet is a concept, a phenomena that happens in diodes called reverse recovery. So when you have a diode on for a certain time, when you turn it off, it has some charges that has to get rid of them when it's turning off, right? So that's why it's called reverse recovery. Basically, it has some charges that has to, basically, when it wants to get disconnected, it has to get rid of them because like there's no current going through it. So like it takes some time to for the diode to recover. Basically goes from the conduction mode to basically open circuit, right? So that's the reverse recovery that we have to take into account for diodes as well. This is related to switching as well. So like switching losses that we saw, one were T on and off for the switches, and the second one is the reverse recovery for diodes, right? So let's actually do a plot of V and I for a diode and see what I mean by reverse recovery. So let's say the diode is, this is like the diode having some current, okay, and